Welcome back, all of you, after lunch. I hope you had a nice lunch, and uh, this is an interesting topic which we will be discussing in this session. So, before I introduce the chair of this session, I'd like to sort of talk about some rules for this session so that we finish on time, and also introduce myself because no one is there to introduce me. So, I'm Amir, and I am the lead researcher in this ASAR project stationed at IIHS. And I've been working on climate change issues for some time now. And I was coordinating the second NatCom process from Delhi, and that's why I know many of these people who are a part of this consultation. So I'll request each speaker to be like very brief, and we hope that in 10 minutes we finish each presentation. 7 minutes I'll sort of flag it off, and so the idea is. So I just wanted to also talk about the idea that we why we wanted to have this session. And since we are in the beginning phase of this project, and most of you are eminent scientists and researchers who have been researching on these issues for so many years, I would like to comment on some of the key research gaps that exist in this domain. And it would be worthwhile to examine those gaps, sort of fill those gaps through research inquiry during the ASAR phase. So that's what we hope to sort of achieve through this process of consultation. And I'm sure we'll have many more such consultations, one-on-one, as well as through such kind of engagements. So I welcome all the speakers and all the sort of listeners who have sort of chosen this session to be a part of it. We had a choice, and thank you very much. So what we'll do is that I'll introduce the chair, and I'll request him to make a few initial remarks, and then I'll introduce each speaker as and when the speaker is requested to make the presentation. So I think that works well. So it's my privilege and honor to introduce Roger Few. He is a senior research fellow at the School of International Development at University of East Anglia, and he has a background in human geography, political ecology, and environment and health in developing countries. His current research focuses on vulnerability and adaptation to natural hazards, disasters, and climate change, with special interest in how households, communities, and institutions respond to the health risks associated with climatic and environmental hazards. His wider research work spans various aspects of vulnerability and response to climatic and environmental hazards, including recent and ongoing projects like relating to forest communities, water stress, environmental justice, disaster risk reduction, disaster recovery, and community resilience to geophysical hazards. He has been publishing regularly and heavily, and is a regular contributor to research groups in climate change and development, global environmental justice, aging and development, health policy and practice. So I invite Roger to make a few initial remarks.
Thank you very much, Amir. I guess you might react to that. It sounds a bit like jack of all trades, master of none. But in a way, I do work on a number of fields. There is a common thread. I won't go into that as such. But the title of this session, Impacts, Vulnerability and Adaptation, I like that because actually what it's emphasizing is there is this need for a kind of a continuum. To recognize if you're going to try and study this problem, it needs to be done in a cross-disciplinary way, not dividing impacts studies from vulnerability studies, from adaptation. It all has to be seen and connected. So thanks for giving me the opportunity to do the sort of welcoming introduction here. Thanks very much. would be great if you sat in the middle, because it's only Salma at the moment. I'm sort of facing, everyone's sort of either on the left or the right. I don't know what that means, but, and how much time have I got to stop me rambling too much?
I think 7 minutes.
Okay, I will stop before the minute hand hits the hour. Okay, so first of all, that idea of cross-disciplinarity continuum. Just a few brief words about the ASAR project and how we're trying to approach this theme in that. In terms of steps, each of we're working in 4 regions, as you may know. So South Asia, East Africa, West Africa, Southern Africa. In each region, we have an initial stage, which is called Regional Diagnostic Study, where we're doing a fairly sort of broad brush assessment, really, laying out the terrain of what are the climate change issues, what are the sorts of responses in society. But then leading to the really sort of in-depth, the really exciting bit of the research is just to look at specific case study areas. Now, they differ in size. Some people are going perhaps focusing much more narrowly to community level, others at district. We're all looking in a kind of a multi-scale way. We're all looking at various other aspects. We had long discussions this morning about, quite making sure that we do have a common thread. So that's it. But then leading from research, trying then to use the information we gain from talking to people, from the research that we do, to try to develop a sort of a visionary approach to adaptation. In the one thing that connects all those environments is that in situations of chronic water stress and changing water stress. And by a visionary approach, I mean thinking outside the box. So beyond what may be considered sort of the sort of narrow technical or technocratic responses to adaptation. One thing that also runs through, and this became clear towards the end of our session this morning, is this focus on change. Now, there's the very obvious climatic change, but we're also looking at how that climate change will play out over a period of time, and that's a period of time when there'll be all sorts of other dynamics, social, political, economic. So we're looking at a dynamic situation. But we're also talking about change in the sense of transformation. And so there's this prospect that climate change adaptation could be transformative, and transformative in 2 possible ways. One, transformative in the way we interact with the environment and resources to make ourselves less vulnerable to future climate change, but also potentially transformative in a broader sense, so that we move towards a more sustainable development, towards a more equitable form of development, towards a form of development that puts people first and their needs first. The other main element that we're trying to get at in ASAR is complexity. So rather than try to reduce the climate change problem down into a neatly solvable package, research is at that point around climate change where it needs to really embrace the complexity of this issue. It has to be understood in the broader system in which climate change impacts and adaptation operate, the broader economic and political system and social system. We need to be looking across scales. We need to be looking at the implications of the way we look at time periods, short-term, long-term adaptation. What's the linkage between them? Is something maladaptive in the short term? Is something that's adaptive in the short term and that maybe brings a maladaptation in the long term, is that necessarily a problem? Under what situations is it such? It's very easy to come out with simple statements, well, that's maladaptive. Probably just about everything we do could be seen as maladaptive in some way. Do we look sectorally, or do we try and look holistically? Do we focus just on the climate problem, or do we couch the climate problem within broader issues of development and development? And then this key point, are we looking at incremental adjustment, shifting what we do, the business as usual approach, or are we looking to do something more transformative? Nearly done. The thing that I would emphasize in this is probably, I have a number of phrases that have come from sort of management speak that I hate, and one of which is win-win. I'm not sure that win-wins ever exist, let alone triple wins or quadruple wins. We're talking about a complex situation. We have to make an intervention. There will always be winners and losers. There will always be trade-offs. But it's up to us as a society to understand what those trade-offs will be. And I would personally argue that it's up to us to try to make sure that those trade-offs don't fall too heavily on those who are least able to manage them. And I think at that point I'll finish and hand over to the speakers.
Thanks, Roger. Those were important comments, and I think the speakers will keep those comments in mind and sort of give us some indication, some kind of a roadmap for future research in the ASAR project. So let's begin with the technical. Then I invite Arivuday Nambi Appadurai. I hope I pronounced it right. He's a strategy head at WRI of the Vulnerability and Adaptation Program. Most of his research work has focused on climate risk management and adaptation to multiple risks in the context of climate variability and change in Asia and Africa. And one of the affiliation which missed out was that prior to joining WRI, he has worked extensively as director of the climate change program at the MS Swaminathan Research Foundation, Chennai. So over to you, Nambi. You have 10 minutes. So another just setting the rules kind of thing that what we'll do, we'll listen to the presentations and we'll have a consolidated feedback session at the end. So keep your questions to yourself, and in the end we'll call all speakers up front and we'll have a question answer session. Thank you.
Thank you, Aziz. At the outset, I'd like to thank IIHS for having me here. Yes, the topic is so huge, climate change impacts vulnerability and adaptation, and I'm given 10 minutes. It's a heavily loaded topic, but still, we need to try to do some justice to that. My outline of my presentation, essentially, it is just flows from what the discussions we had during the morning session, kind of some conceptual thoughts and vulnerability assessment. My primary focus will be on the vulnerability assessment side, and also some insights from practice from the kind of projects we implemented and what lessons we learned, how it could feed into this. I will rush you through some of the slides. When you talk about impacts, it happens at two levels. One at the biological systems where the productivity, quality, and population are at stake. And when it comes to societal systems, it's more the impact could be construed in terms of income, morbidity, mobility, mortality, and other measures of well-being. That's the important thing. Impacts are so heavy. And how do we measure impacts? Impact on an event is a product of intensity of an event, and the baseline, existing baseline conditions is an important factor in that, as well as the adaptive capacity. I'll go back to it a little later on the adaptive, what do we mean by adaptive capacity? And vulnerability in the climate context is defined as the extent to which climate change may damage or harm a system. I know these people, the people assembled here are well informed about this thing, but some of them are stating the obvious, but still it is important for us to kind of set a context to that. That's the reason I'm just presenting this. And the key drivers, one should not forget that climate change is one among those factors, one among the drivers. Oftentimes it's thought that it's everything. It's not so. That's important to keep in mind. There are several factors like globalization, urbanization, demographic changes, technology. All these are kind of leading to vulnerability. And particularly the shocks, fluctuation, and trends which determine the extent of vulnerability, which has a direct impact on the local resource base, which in turn affects our well-being. The 5 assets, generally what is well known to everybody, that gets affected. That's the kind of framework what you have. And again, it comes on, it has a very good disciplinary bias. It all depends on where you come from, what discipline you come from. For the DRR community, vulnerability is a set of damage functions. Vulnerability is a social, economic, and geographical exposure to hazard. If it's a high cyclone or drought or whatever is it. Whereas for the poverty people, it is a risk of adverse consequences affecting livelihood security. And that's where they come from. And for the climate community, is a function of exposure, sensitivity, and adaptive capacity. The purpose of vulnerability assessment is twofold. One is generally to understand what is affected, how and when and how. And also to kind of, what kind of response option based on our understanding we devise. It helps in that context. Other one is to inform policymakers what's happening, how it is really moving, what is the future scenario, etc. And there are umpteen number of methods and models, and methods or models do not provide answers. I beg to differ from morning session. We cannot escape models. That's not so. To some extent, it might guide us, but then it is not everything because there is a human behavior, a social fabric. Unless you understand the social fabric of it, it is not going to help us anywhere. The science. What is the use of science without society? So it's important to kind of embed those science in the societal values and stuff. So that's important to me. And I mean, there are a lot of literature coming out in that direction today. The first step is to consider the questions of what is being asked. As far as vulnerability is concerned, we have to really look at what is at stake, what, how, when, where. These are the 4 questions one has to answer. Who may be affected? Who are the vulnerable groups whom we are kind of help out? How far in the future is of concern? That's another question. And what for purpose is assessment, which I touched upon earlier, and what kind of output is needed? This pretty much determines the kind of a framework what we look at. And other key considerations which are needed are the driving of, the factors that are driving the changes and implications of the future, which I mentioned. And also, we have to look both in tandem, climatic and non-climatic exposures operating on. That's important because these are very synergetic and it is very important to, it's very difficult to, delineate these things. That's because the first order, second order, third order, climate change probably in the third order. So it's important to be cognizant of that fact. And vulnerability indicators are very important topic area, one of the very, very highly disputed area as well. There are a lot of opinions about it because there are certain things which are, when you look through the climate lens, it is important to some non-negotiable indicators are there, which is certainly should be there, like temperature and other things, other climatic related factors, sea level rise and stuff. And also one should understand the critical thresholds of climate variables, which unless we identify that, we can't devise a good action plan. That's important. And also, primarily, we always look at the system level. We are not going to subunits of resource use, resource system. That's another thing which you have to be looked at. We have to break the sector into different subunits and see how vulnerable they are. That's another important lesson what we learned from our own project experiences. And choosing tools is very important. There are a variety of tools available today from qualitative to quantitative. Again, oftentimes these two people don't come together. That's another thing. There is quite a bit of debate on that aspect. And where do you draw the line is a constant question. And from participatory to data-driven, from complex model to transparent processes, and from descriptive to prescriptive. And choosing tools becomes very, very important. We have to be very practical. Different tools will be appropriate for different purposes. So the context pretty much defines the kind of framework and the tools, what we choose. And particularly when you're looking through climate change lens, then things are, the indicators are different. So one has to be really, cognizant of that fact as well. Again, there are different types of assessment, scenario-led assessment, what people talked about mostly based on the models and stuff. And there is a participative vulnerability assessment promoted by CARE International, and risk and local capacities mapping, which is generally being dealt by the DRR community, disaster risk reduction community, which has lots of values. Again, DRR community is not really going along with the adaptation community. There are certain initiatives which is trying to kind of bring synergy to these because there's a lot of experience lying down there with the DRR community. Again, the use matters. To whom, as I mentioned to you, what is the purpose of this? If, for example, at the international level, if UNFCCC is doing, then it is they're doing some cross-comparative analysis between nations and essentially to kind of allocate funding, allocate resources. Then the purpose is different. Whereas the regional level, it's more of resource sharing, then the vulnerability perspective should be a little different. Whereas the local level, it's mostly to do with the poverty alleviation and project design and implementation should kind of take that consideration into the fact across the sectors, what I've mentioned here. So there are different scales in which you operate. Also, again, there are two types of frameworks, first generation or top-down, and second generation or bottom-up. Where do we meet? That's an interesting question. This is a very interesting slide where it is kind of totally driven by models and stuff. It's more to do to the assessment of the physical vulnerabilities, whereas with the social vulnerabilities, there are umpteen number of other factors. The indicators are a little different here, and somewhere they have to come together, basically. And this is a regularly understood framework, conceptual framework where we have Uncertainties, the only certain thing about climate change is uncertainty. So we have to deal with it, either we like it or not. Then, then how to convert them into risk. Unless you convert them into risk, you cannot understand the vulnerable elements associated with that. Then once you understand that, then you have an adaptation plan. The gaps and needs, again, it's very much stems from the uncertainties what I'm talking about. There are data needs, there are not much of data. Morning also it came up time and again, that is an issue. And vulnerability indicators, how they might change in future. That's another, we have to take it with a pinch of salt, Again, 2030s and short term is very easier to predict than looking into the 2000s or, 2050s and stuff. And adaptation, we need not really talk about much, an adjustment process, as you all know. But what I'm trying to stress here is the function of wealth, technology, education, information, infrastructure, social capital. These determines pretty much the capacity what people have. That determines how we kind of reduce the vulnerability. Again, having adaptive capacity does not mean that it is used effectively. So how do we that's an important thing. So now I move on to the project experience what we had. This is a project what we implemented when I was the director of the climate change program at the M.S. Swaminathan Research Foundation. This is one of the very interesting projects, one of the early people who have been working on that in 2004. Very important lessons, and people have not been talking about adaptation then, in that sense, what has been today. So that way, it also fed into the policy process. We had a wonderful policy dialogue after that. It has a threefold objective, like enhancing the adaptive capacity, improving the delivery systems, and how to inform policy. This one slide explains to you, in terms of the, through a participatory process, we documented the available information there, the capacities, the knowledge and technologies and action learning, and use this, develop some storylines based on that, which in turn is used to leverage policy. That's the kind of idea. And to some extent, we are successful in that. These are the project is basically on semi-arid regions. So we worked in Rajasthan and Andhra Pradesh. And there are different kinds of, based interventions. These are not rocket science, it's all what under the development area, what we've been working on, but still only thing is bringing the climate perspective to that. We see everything through the climate lens and what information, what we have, how it could be captured, how it could be improved on with implementation of some modern science. That's the kind of idea. Specifically, these are water-related interventions, particularly when I talk about climate change, adaptation, a sense of history is very, very important. So we cannot totally come out with some new formulas there. So again, I'm not going to spend. That's another thing which I want to mention. This is one of the first ever experiment what we had on the agromet stations. Of course, a lot of people have jumped into the bandwagon today and they're working on different scales. But that is the very first kind of where village level climate risk management was mooted, and we trained people in that kind of a thing, where we're simple instruments. For example, the wind speed is more than 10 kilometers per hour. It's not an ideal day for taking up spraying. So they generate the information there, they designate the information there, and then it saves resources. That's the idea behind it. So knowledge management becomes a very key element in this whole process. And awareness. To me, there are three things which are important. The catalytic intervention, what you bring in. The adaptation, appropriate technologies are very important, social mobilization and awareness. These are the three important lessons what we learned. And some of the important notable insights, right types and right combination of assessments are needed to start with. Unless you have good information, you cannot plan well. And also it's an iterative process. Adaptation is something iterative. So M&D is very important, monitoring and evaluation, where science is advancing, the thought process is advancing, but still we are not yet there to evolve separate M&D strategies for adaptation. That's very important. Successful technology demonstration, social capital, networks, that's also important. And also we should remember that people always look for long-term solutions. That's important to keep in mind. So, and strategic investment in infrastructure, be it a small agromet station or a check dam or whatever is it, we have to really look into that very carefully. And my conclusions, comprehensive vulnerability assessment leads to good adaptation. So whatever is the input-output model, basically how sound is your adaptation pretty much determines how good your vulnerability assessment determines how good your adaptation is. And choice of tools and method is determined by the context, as I mentioned earlier. Involvement of the vulnerable communities, that's important. The stakeholder involvement is very, very key. For example, in that particular project where we work, first step is even before the project formulation, we went into the people to consult from Andhra Pradesh, from all the districts. We have 2 farmers and try to understand what they mean by vulnerability, what its adaptation means to them, what it means to them. vulnerability, there is no equivalent word in Telugu for vulnerability. We realize that. So we have to kind of struggle hard to get the concept right. So adaptation options must be consistent with national development plans. Otherwise, it doesn't make sense. So we need to really look from the planning perspective as well. Somebody asked about the question this morning, how it percolates down the local governments and stuff. So we have to be really geared up for that, unless, because it's very location specific adaptation. So there is no blanket policy for adaptation. That's all important for us to keep in mind. So I'll stop here, and that's a pretty express kind of presentation for you guys. But,
Thank you. Thank you so much. So now we have 3 back-to-back agriculture presentations. Very interesting, very important, and one of the most critical areas in this project. So let me take this opportunity to invite Dr. S. Naresh Kumar, Principal Scientist at Indian Agricultural Research Institute. He's been very humble in mentioning his sort of interventions. In fact, we have been following his work for quite some time now. He does a lot of crop modeling work and is a part of a very important national initiative on climate resilient agriculture led by some of the lead agricultural research institutes in the country. Thank you.
Thanks for, first of all, having me here and having a nice introduction, which I try to match up to. I think I am audible. Okay, thank you. So what I would be taking you through for last, next 10 minutes or so is what India has been doing from the climate change and Indian agriculture point of view. The climate change for the agriculture perspective is dealt mainly by the Indian Agriculture Research Institutes, Indian Council of Agriculture Research. It has around 100 plus institutes, like major institutes like IARI, CREDA, and so on and so forth. And you have state agriculture universities, Ministry of Environment and Forest, and including DST is there, then Swaminathan Research Foundation, NGOs, several NGOs are also there. All of them are looking and trying related to farmers when it comes to climatic risks. ICR has several initiatives. First, there were several studies which were going on prior to 2002, but in 2002 there was a concerted effort in the form of network project of 23 institutes located in different parts of country and addressing several aspects of agriculture, including crops, horticulture, maybe fisheries, animal husbandry, and so on and so forth. Then it is upscaled in 2011 to National Initiative on Climate Resilient Agriculture, which is in mission mode type of thing. So now we are into next plan of this particular initiative. So I would like to briefly again go back into the what IPCC tells for the Indian region, South Asian region, that warming and extreme temperatures are going to be more frequent, rainfall events and skewed monsoon. Our agriculture is monsoon dependent, and you have increased risk of drought related water and food shortage. It's going to be even more severe. However, they go on to tell that all will not be that bad if we really adapt at present rate, adapt at intensive rate, you can really overcome some of these. And that's where we are all putting our efforts to overcome such risks. So I would like to share some of our own, there have been several examples of how crops and agriculture related commodities or systems are getting affected because of extreme climate events. It need not be extreme climate events, even a bad monsoon or skewed rainfall distribution severely influences the Indian agriculture production. For example, in 2002, 15 million hectares were affected, affecting around 10% of the food production because of the low rainfall season. And this year also we are likely to have less production because of low rainfall, particularly during this crop maturation period when the grain filling is happening. If crops are not having enough water, then they are likely to have reduced yields. And then you have terminal heat stress, in wheat is affecting the productivity in eastern India and parts of central India. Similarly, you have cold waves, heat waves, they have been happening. Extreme rainfall events not only affect the annual crops but also the perennial crops. And the shift in apple cultivation is one more to higher levels in Himachal, higher elevations, is attributed partly due to non-fulfillment of the chilling requirement because of the warm, less production of the milk. So what we tried is to understand these impacts in a larger scale. So we try to have some of the high intensive research methodologies and some of the process based model, which is indigenously developed at our own lab at IARI. And this one we use to come out with some of the assessments which are widely quoted in IBCC report. Now, the 2020 scenario, if we don't really adapt, we may lose some of the yields of productivity of the major crops anywhere between 2 to 6%. However, some of the crops may really benefit because of some of the optimal temperatures moving towards optimum from the current suboptimal level. That is, if we don't adapt. However, if we adapt by having simple and very low cost technologies like change in the sowing date based on some scientifically analyzed data, then change in adapt suitable variety, then irrigation efficiency and so on and so forth, you can really increase the yields. And such interventions can increase the impact areas of wheat from this situation to this situation in future. But some of those regions still may remain vulnerable. For that, we need to have more and more intensive adaptation strategies. So adaptation can really increase the yields significantly from 10 to 25%. Therefore, adaptation, when we talk, we need to take care of two things. One is mean changes, another is increased variability. Increased variability, when we talk again, extreme events and day-to-day weather extremes, they become more important when it comes to adaptation in agriculture. We try to implement this particular concept in 4 of the districts in India. One is in Haryana, central India, in western India, and in eastern India. 2 districts of them are drought prone, 2 of them are flood prone. So what we try to do is in 52 villages to the extent of around 15,000 farmers, we try to cover his concerns and many. But it is not possible to really cover all the concerns of the farmer. But what we try to do is to enable him and show him that yes, with some simple analysis and adaptation, he can overcome some of these risks. At least he can minimize the losses. So what we did, we strategized the adaptation by having the resources analysis for those villages, and then vulnerability assessments, and then simulation analysis also is one. I do agree with Nambi that simulation can help in better decision making, but it doesn't do work for you. That is what we need to use simulations at very discrete way. And then you have stakeholder analysis. Ultimately, he is the one who is going to adapt or don't adapt, or listen or don't listen. So that we try to do, and ultimately we came out with an adaptation strategy based on the 5 capitals. For this audience, I don't really have to explain what are the 5 capitals. So, and what we try to do is analyze the climatic risk, resource constraint analysis for those villages. Then you have introduction of improved varieties, diversification, improvement in crop management, development of seed village. This is one big success story for us. And water management, laser leveling, then zero till, and so on and so forth. Then you have value addition, then secondary skill development for income augmentation and enabling the farmer with the information, like mobile technology we used. Just I would like to show how simulations we used. We try to simulate 2000 farmers' data and see what they have been using. They have been using long duration variety. If the long duration variety, when they are using, a farmer who is providing good management in a good year will get higher yields. But in a year where the temperatures are going up, the good management farmer also loses heavily, because the predominant factor here is temperature. When we change that to short duration variety, change in the sowing time, the simulation analysis indicates that your differences among the farmers as far as the productivity is concerned, it is mainly because of the management level. You are overcoming the stress level of the temperature. That's ruled out now. So this we try to implement in farmers field. This is around 3000 plus farmers field data. The shift in yield levels happened when we changed with the improved varieties. The farmers who are getting low yield shifted to higher yield levels. Okay. With the farmers who are having still the local varieties continue to get this type of distribution. So the distribution shifted to higher level. Similarly, we have for other crops. And these are some of the technologies we try to implement, like laser leveling. You have sprinkler irrigation, you have drip irrigation, you have some of the uh, shade nets for better nursery of the horticultural crops. So that you have vigorous horticultural crop nursery, you have better yields. Then you have again the weather station. This is what we try to do through mobile technology. This is a two-way communication. We try to develop a system in consultation, in collaboration with Tata Consultancy Limited. They have a M-Krishi, and this is now commercialized as Docomo. 30 rupees per month, the farmer can really subscribe to this. In those 4 districts, they are yet to upscale to, we are probably going to next phase of upscaling this to national level. So this is what we try to do using the other training programs for developing the secondary skills of the farm and farm families, so that their income is diversified as well as they will get better risk covering capabilities. Now, what we try to do is, there's always a question mark that whether the adaptation really costs. If so, how much? So we try to analyze by having some household level intensive data. Here we try to do marginal farmers, small farmers, and medium farmers. We have taken from the intervention farms as well as non-intervention farms from the same village, and non-intervention farms from the other village, so that percolation, knowledge percolation, all those things we can account for. Now, when we look at a marginal farmer, by having little intervention of adaptation cost, he can have improved his income much better way. A small and medium farmers, particularly small farmer, if he doesn't really have to put extra money. All that he has to do is do things in a better way. That means even without adding any additional penny, he can get additional income through following the technologies. He is already investing a lot, but that needs to be fine-tuned. A medium farmer, of course, he has to invest maybe for other infrastructure development, but his returns will be not so high. So this story tells that adaptation doesn't cost always, one thing, and adaptation benefits are not uniform across the society. For that, we are trying to now upscale this type of concepts to national level through NICRA. And what we try to do is to have all the resources mapped as well as at the spatial level, and take this government and developmental institutions, farmers, research institutions, KVKs, and so on and so forth in fold, come out with the integrated assessments, implement all those so that we can have adaptation strategy domains. Adaptation strategies as well as adaptation domains. We are trying to develop these things so that we will have a better adapted and climatically resilient agriculture in India. For that, of course, we need to prioritize the technologies. And it is rightly said that adaptation and mitigation cannot go separately. They are hand in hand. And we are trying to see the adaptation, mitigation co-benefits from the adaptation activities. With this, I think I would thank the organizers, and I think we all need to converge to de-stress the agriculture, and our activities and the decision making crucial points. What is that we are trying to decide at each level that ultimately probably lead to, need not be world, I mean, even a household level. That is what happens, whether a household is going towards positive side or it is being checked because of different threats at different levels. So the decision making at crucial points become very, very important. Thank you.
Thank you, Dr. Naresh Kumar. So now I'll invite Dr. C.H. Srinivas Rao. He is the Director, Central Research Institute on Dryland Agriculture. He also co-leads the NICRA initiative, that's the National Initiative on Climate Resilient Agriculture. His research areas are mainly integrated nutrient management, soil health and soil quality, carbon sequestration, watershed management, resource characterization, and of course he has a PhD in soil science and agricultural chemistry. Thank you.
Yeah, thank you very much. Thank you for inviting me and giving this opportunity. And let me clarify this. This is third presentation, and almost because we are working together, so it is the extension of those projects. Of course, first presentation was made a little earlier, but previous speaker, Dr. Naresh Kumar, and my presentation is more or less similar in the sense that we are the partners in the same project. And in fact, the presentation made by previous speaker, because since some of the repetitions are there, I would like to few seconds to clarify. So basically it is covered Indo-Gangetic plains where irrigated agriculture is majorly. So but here what we'll be presenting is in similar line, but in very vast, the entire India program we are making. Instead of 4 districts, we are implementing 150 districts. So it's such a large extent. So otherwise, essence and methodology and things are similar. So climate change in Indian agriculture, what it means is that we have actually basic, this is a large country with different agroclimatic conditions. If you take any European countries, other countries, but all different, 8 type of soil orders, 8 type of agroclimatic ecologies, everything is available in India. So any climate change aspects is very complex here, and diverse seasons and crops and farming systems, high monsoon dependency, close link between climate and water resources, 2/3 of area is rain dependent, and small holders, as my previous speaker told. So ultimately this essence is that our Indian agriculture, we wanted to see that more resilient Indian agriculture is the overall goal of this climate change project. So this I wanted to say that at the national level, if food production is this much, you can see here that, but monsoon variability, you can see the percentage of monsoon variability, it is almost 7 to 100%. So this is the so variable rainfall, but we need to get, at present we have 265 million tons of food production, but the projection is that we need to produce another 50, 60 if two-third rainfall, country is rain dependent, such a variability in rainfall. So adaptation, as I agreed, that it's a very crucial, but since just like climate change, adaptation strategies are so complex because it's the climate change is a simple parameter, but the Indian context, socio-economic conditions really makes a lot of difference. So anyway, this was presented previously, but I wanted to focus this year current what happened to this is Seaway Drought year, as Naresh Kumar presented 2002 drought, 2009-10 also affected, but this is another form of drought. See, onset and advancement, what happened here is that we are supposed to get the rainfall by June first week or June 1st or this, but this is almost 1.5 month delay was there. So from June 1st to almost July 17th, entire country. The problem is that if we take June rainfall, July, these are the cropping system of southwest monsoon, and almost there is a still deviation 92, 163, and this is. But if you this picture is not much scary. If you see. This is the most important for agriculture point of view. If you take any weekly data, so almost in every case there is a huge deviation. You can see most of the cases at the critical crop stages, this rainfall is deficiency. So this is important parameter. If you take average rainfall and these things will not make it crucial at weekly distribution of rainfall is very important. So this is the scenario this year where. And some of the impacts I will skip because of paucity of time. He has told already impacts. So why vulnerability also I will be skipping. He explained nicely that how vulnerability is important. But would like to make same IPCC model we have also prepared, and these are the parameters. So these are the procedures. So finally, based on these data, what is the drought incidence and area prone to floods and the cyclone preparedness. So ultimately, we have made single map that this is integrated vulnerability. How this you can see that vulnerability is very low, and medium, and very high. So as he mentioned, Dr. Nambi, so these things will be useful. Purpose is same. But if you see that the state-wise distribution of vulnerability, you can see here that red indicates very high and gradually this northeast regions. So this is the individual state-wise vulnerability index. So what adaptation, some of the points were told by a previous speaker, but like seed banks, village seed banks. So we would be sharing because of this 140, 160 disease experiences. If we make that, so in India, because of complex system, you wanted to put any impact, we need to have larger schemes, larger demonstrations. So in this project, for example, just I'll be telling that previous speaker also mentioned that how technology for adaptation like tree cultivation, like how it looks, this is water saving technology. This is then coming to what I was telling about NICRA project, it is in 5 years it is $100 million. This government is contributing $100 million. So every year it is a $20 million. But it's CREDA is a lead institute implementing this program. But we have around 32 partners, like National Institute, IR is one of the partners, maybe even now Swaminathan Foundation, several partners are there. And basically there are 3 components: resilience to Indian agriculture, to demonstrate upscaling in the farmers' fields. Third one is a capacity building, because it is an emerging subject as far as many rain-fed conditions, rain-fed villages. So awareness and capacity building is very important. And we have this strategic research, technology demonstration, and capacity building, and sponsored and competitive projects. So this is in a way that impact can be managed with proper variety, with current management, alternate management. And so with the existing, what the message out of this is that with existing technologies, with improved drought tolerant varieties, better water saving systems, better nutrient management, other conditions, we can make system very resilient, not individual components. As a package of things have to go to make this important strategy for any adaptation strategy. So these are the, as far as dryland agriculture and rain-fed, where 2/3 India is there, intercropping is the best technology. But you can ask me the discussion that why intercropping is not such a climate-friendly technology, to what extent intercropping, why it is not completely being followed. So these are the, it's a very beautiful, this year especially it has come. For example, Anantapur district, it's a arid district of Andhra Pradesh. Here, morning Ravi was also telling. This year, out of average rainfall was 520 mm. This year so far happened 152 mm rainfall. So in those conditions, what Ravi was telling that how this 3 days back I was there, they were made some government scheme primary mission. But such those conditions, we have to adaptation and mitigation things if we bring to those conditions. So how complex these? So shelter belts, some of the examples just I am mentioning. So we need to have, because based on Maharashtra, this is the important thing, and some of the regions, suppose in these vulnerable districts, the choice is that if you want to take custard apple orchards or mango orchards. In 2009 drought, this is the scenario, mango orchards were completely dried up where custard apples sustained. So it is very important in the technology-led policy morning, it was very nicely explained that these are the some of the cold wave and frost resistant, frost management things, and bed planting, and you can see here that BBF. And this is the resilient. For example, at Hyderabad, it is with 700 mm rainfall, where monocropping is practiced. With conservation agriculture system, cropping intensity was doubled. We were able to take second crop in the monocropped area. So these are the, suppose I will be skipping. So this is the technology demonstration component under NICRA, where second component. So these are the 130 districts, and 30 districts more have been added now. So these are the vulnerabilities. I just quickly go. These are the, when the project was launched in 2011, we wanted to bring a lot of awareness on climate change. So in 100 districts, all these districts, we have started this project in a very big way, so that policy makers and district officials, line departments will be part of that. So awareness will be large scale, and what we are trying, for example, this adaptation and mitigation as well as nitrogen fertilizer is concerned. I will take one example. For example, in a village, 200 farmers are there. At least 50 farmers or 25 farmers, even 10 farmers reduce 10 kilos of nitrogen, urea fertilizers, how it contributes to energy saving, how it contributes to nitrous oxide emissions. So such a way that small at household levels converted into large scale schemes. So this impacts will be much higher. So like that, we have started this 100 in a big way to bring a lot of awareness, and some of these technologies, how this. Then another important point is that in a way that some of the speakers morning presented that contingency plans. CREDA has prepared district contingency plan. Some of the audience, somebody asked that how to reach the ground scale. That is important. Upscaling is very important. CREDA has made 600 district contingency plans. It means that if rainfall is delayed for 1 week, 2 weeks, 3 weeks, if onset of rainfall is okay, but mid-season droughts are there, what is the variety change, what is the crop change, what are the agronomic management is required, and how fodder systems can be managed. So like that, this plan is, purpose is that for district administration, if any weather aberration comes, what decisions you can take, how to go with the ground level. So like that, we have completed so far 580 districts. Those things are available in Ministry of Agriculture website as well as CREDA website. And the conclusions are there that some of the adaptation options are gradual, climate change are available, which need to be promoted with a region specific approach. As I told in introductory that we have whatever agroecologies are available in the world, we have in India. So that's why location technology should be different, approach should be different, and impacts and even benefits also will be different. So real challenge is to develop adaptation strategies to extreme events. Effective extension services, policy support are critical for adaptation to climate change. And the small and marginal farmers need to be special incentives, because 1 acre, 2 acres in what I have told about Anantapur district farmer is getting 2,000 rupees, means 4,000 rupees income per acre. It is hardly $10, $20, $30. Those farmers, if you go, you adopt climate resilient technologies, you adapt, go for this, these things will not matter for them. For him is first that season food is important, and off season fodder is important for his animals. And that's why we need to have some incentive basis, incentives are required for such a small farmers. And the point you have spoken that you have to raise some of the points, gaps in research, and the most of these things I would like to tell this. There are, as far as climate change adaptation strategies are concerned, in India, lot of technologies are available, lot of potential technologies are available, and impacts were also shown to a limited extent. Suppose as a research organization, if I take any management, any demonstrations, I will cover 2 villages, 3 villages at the same time, maximum 4 or 5 villages. And entire my career of 30 years, I may cover 10, 15 villages. But thing is that we need to, upscaling is important. And the entire system should be involved, and large scale government schemes are coming. Thanks to Government of India, we have big project, National Mission on Sustainable Agriculture. So all these 4 components, rainwater management, rain-fed agriculture, soil health, and climate change, these 4 important avenues are there to upscale all these technologies. Hopefully, so this is the knowledge is there, and as Ramesh was telling from ministry, upscaling is important. Upscaling at awareness and farmer level, that is a crucial. If we make small change in the village, and people are ready to take it, but a small intervention, these things, and I think it will flourish like anything. Thank you very much.
Thank you, Dr. Rao. And I was observing the map, the vulnerability profiling map, and I was happy when I saw that, not in a bad way, that there are some vulnerable districts, but the transects that we have selected are lying in some of the high vulnerable areas. So that sort of sets the agenda and sort of makes this research important. So let me invite Dr. V. Geeta Lakshmi. She is a very senior faculty with the Tamil Nadu Agricultural University, Coimbatore. She has more than 17 years of teaching and research experience in location-specific seasonal rainfall prediction, weather-based agro-advisory development, services development, climate change and its impact on agriculture, and also crop weather modeling. And quite a bit of her work has been on the area which we are researching in Tamil Nadu. So.
Thank you very much. First of all, I thank the organizers for inviting me to this important conference. And by this time, the audience must be understanding how difficult it would be for me to talk the same topic after 3 veterans have talked about that. But still, I would like to justify, because they have all talked about the larger area, but I will just talk about this subject on smaller area, how we can tackle this climate change at a project level. Okay, so I think the introduction is quite similar to everyone else, what they have said, like it affects millions of people and it is of high priority, especially the agriculture sector. And increase in greenhouse concentrations in the atmosphere is also because of faulty agriculture activities. So we need to think about the mitigation as well. And then there are major threats to crop production in India because of the increase in temperature, decrease in rainfall, and frequent extreme events. And the most important thing is there is an yield plateau. How much ever inputs you put on the field, but there is a plateau in the yield. Now the research is on breaking the yield barrier. So then developing suitable location-specific adaptation technologies is the key thing which we all need to think about. Okay, so I think this is one of the important things which we all know about it. So the first thing is, like, these are the climatic drivers: higher ambient temperature, erratic rainfall, and these are the leading impacts like higher sea surface temperature, sea level rise, and so on. And this leads to, these are the impacts, direct impacts: soil erosion and loss of soil nutrients, emergence of new pests and diseases, loss of crop biodiversity, possible extension of dryland areas. All this can happen with saline water intrusion as well. And because of that, the socio-economic impact is loss of food and livelihood security, and hence the income. Okay, so the key vulnerabilities, I think I can better skip this because already the Director Krida has talked about it. Mostly dry land, per capita land holding is less, and so on. So these are mostly the possible impacts of climate change we see in agriculture. One is increase in carbon dioxide is happening, which will have definitely positive impact on the crops, but it is not happening alone. It's also happening along with the increase in temperature. So the increase in temperature impact to a certain extent will be nullified by this carbon dioxide. So we always have to think about this in terms of combining. So change in crop water requirement is another important issue, which we have done it, and I'll show some of the results on that. Then another thing is fertilizer use efficiency and greenhouse gas emissions. This is going to be very different from the current condition. Then latitudinal effect, population dynamic of pest and disease, extreme weather events, and so on. So whenever we think about climate change assessment, these are the steps which we all know: analysis of current climate, developing future climate, risk assessment, adaptation strategy development, and then integrating climate information in the risk management and adaptation planning. So I just would like to quote a few examples because my earlier speakers have talked on national scale. I thought I can just talk on regional scale. So this is one such experiment which we have made it. So here the maximum and minimum temperatures are increasing with the last 100 years. We have one project worked with the international community which was called Climarize. So through this project we could develop some of these graphs. So this is one study which was made as a part of it. We have looked into long-term trends in rainfall from 1950 to 2010, and it says that if you could see the October through December, that is the northeast monsoon we call, the rainfall has really increased, especially in the coastal areas of Tamil Nadu as well as the Andhra Pradesh region. Whereas the southwest monsoon, there is a decrease in rainfall tendency noticed. This is the observed climatic trend which we have observed. And then if you could see, this is the temperature. There is consistent increase over the time in both southwest as well as northeast monsoon time period. And we also looked into like how the other important parameters such as El Nino, which is having a greater say in about the monsoon of the world, so how it could affect the local level at a kind of a region, major region. We could see that there is a lot of information could be derived because it is not showing a uniform pattern. Though it is a global phenomena, the impact is at local level is very different. We could see that there are in both the El Nino condition as well as in the La Nina condition, both southwest and northeast monsoon had differential impact, spatial impact on Tamil Nadu rainfall. So this is the one of the study which we made it. So again, we could see that there are some other parameters also we can look into in terms of variability in climate, which is Indian Ocean dipole. This study also we made it. And then we just started thinking about how these things could be integrated in the managemental aspects. And we have seen that this particular thing is based on the El Nino, La Nina and normal years, how the hydrology of a particular location, especially we have seen at a river basin scale, how it could be impacted. So this is about the rainfall. So this is the rainfall condition in El Nino years, La Nina years and the normal years, and how the other hydrological parameters are changing. And resultant impact, we also have seen it on the crop level. So this is the rice productivity which is influenced by the El Nino Southern Oscillation Index conditions. We could see that the mean rice productivity itself could be increased in the El Nino years. So the point which I want to stress here is we have to also take these opportunities into account and try to introduce some of the technologies as well as some of the varieties when the El Nino forecast is given, especially for the Tamil Nadu region. So this kind of analysis also would help in improving the yield in the later conditions. Okay, now coming to climate change projections. So this we have done it again for the same Kaveri Delta region. We could see that the temperature would be increasing by 0.5 to 1.2 degrees Celsius by 2020 and so on. And this is one such projection which we have made for the entire regions of Tamil Nadu through a different NATCOM project studies, and these are for 20 different time period, near century, mid-century and the end century. The similar things we have also attempted to minimum temperature and also for rainfall. So these kind of things, always we have to take it with a pinch of salt because this involves with a lot of uncertainty. So to study that uncertainty issues through another project, which is from the AGMIP project, we have tackled that with using 20 different models and taking, this is done for a particular region, one region in Adurai, which is a part of rice growing region in Tamil Nadu, another one for the semi-arid tropical region, very dry region, this is for a maize growing region. We have just seen this black dot is the current climatic condition. This is the 28 degree Celsius temperature during the southwest monsoon time period, September, October, November and December. This is the mean temperature with the precipitation level, daily precipitation, mm per day. So how this will be impacted in the future? So this we have just modeled it with the 2050 scenario for the RCP 8.5. So this says that you can very well find out that there are a lot of uncertainty is existing with the different models, 20 different models. So what we have done is we have picked 5 different models and we have further investigated its impact. So this we could see that for the Adurai region, so this first graph on the top, it says that this is the temperature. The black color line is the current temperature of monthly temperature, whereas this is the projected temperature. You can just see in all the models, we could see that there is a consistent increase in temperature, and this particular bit actually says that how the different seasonal, this is the annual temperature, this is the pre-monsoon, then monsoon season, pre-monsoon and October, November, December post-monsoon season, how the temperatures would increase. So there is a consistent increase in the temperature could be observed. But when we just look into the rainfall in both the regions, both in Adurai as well as in Coimbatore region, we found that this is our major rainy season. Lot of uncertainty could be noticed. We find that there is going to be increase in rainfall during our seasonal rainfall period, and that will have definitely a different impact. So we have seen like what impact it would have. There is actually 10 to 20% increase in northeast monsoon is projected for those 2 study regions. So this will have these many implications. For example, drainage and flood problems are likely to exacerbate in lower part of the delta region of Kaveri and other plain regions. So this is our major finding we could find out. And then more inland areas to have saline groundwater as sea level rise and cyclone storm surge intensities would become higher. So this is another observations, another prediction we could make. There will be higher runoff in the hilly areas. So these are some of the things which we could project it for the water level. And then the same thing, decrease in southwest monsoon is projected. So for that, there will be increase in demand for irrigation water because the temperatures are shooting up, but at the same time, the water level is going to come down. Then increase in demand for groundwater will also be there because there is no limitation for extraction of groundwater. The farmers will tend to take as much as water as possible. So in that particular context, increase in demand for groundwater will also be there. Then marginal increase in evapotranspiration will be there. There will be moderate increase in water demand by crops. So these are the things which we could take it from our studies. Okay, what are the strategies we can follow? So, ensuring water security, integrated topographical approach with appropriate scientific and policy inputs. So what we have done is, we have taken SWAT model for analyzing this, and we have identified for different sub-basins what is the water level available and how much water would be used by crops and how much water would go as waste, how to stop that wastage, those kind of interventions which we have taken it. So these are some of the points given for that. Okay, coming to the impact on crops. So first thing is ensuring food and livelihood security in a changing climate scenario is our motto. For that, these are the approaches. One is focus on farm level crop management, either integrated pest management, nutrient management, soil and water management, adjusting the sowing dates and crop diversification. This would be our major thing. Then promoting crop varieties that are indigenous and are thermal resistant. So in this case, we have very good experience. Like we worked with in the Nagapattinam region, which is very close to the coastal region, wherein the farmers used to cultivate one particular variety. It's a local variety which is called Kulivedichan. So this variety, this will withstand both drought as well as flood, and it will give some amount of yield, but which cannot be compared with the normal recommended varieties. But those kind of things, what we have to do is, in the case of drought condition, that variety will perform better than the varieties which we recommend to the farming community. So those kind of things we have to always take into consideration and then use for breeding programs. So that is our recommendation there. Then promoting risk mitigation through crop insurance is another important thing. Then efficient farm management techniques, then regular training and capacity building. So these are the things which will help in maneuvering the situation. This is one particular experiment which we have done it at farm level with 20 different climate scenarios, how the income yield will be changing in a particular case. So the down case all are the rain-fed ones and the upper cases are all in irrigated. So you can just see how much would be the variation in yield in the 20 different scenarios with the different farming conditions. So this kind of an uncertainty will always be there. This depends upon, again, what model we are using, what climate things which we are taking it up, and those kind of issues will always be there. Okay, so now coming to local adaptation technologies. So this is one thing which we have found it again from our project, percentage change in irrigation water demand during mid and end century in the Delta region. So this is the mid-century change, this is the end century change. You can just see how much would be the increase in demand for the irrigation water. Okay, so this again for different crops. For maize, how the productivity will be changing, and this is for the sorghum productivity, how it will be changing for the different conditions. So these are how to minimize the negative effect. Again, these things have been stressed by Dr. Naresh and the CRIDA director, like the change in the management practices, development of resource conservation technologies, improved land use and natural resources, improved risk management, including early warning and contingency plans, all those things. And then reducing greenhouse gas emission from agriculture. This is mainly by management practices, especially whenever needed, the fertilizers can be applied. Otherwise, we can just skip over. So these kind of things will definitely help. So Ajil would take only 2 minutes to just tell you about what work we have done in this particular project, which will be controlling the management practices at the local level. So this is the Kaveri Basin, what you are seeing here. There are 2 different areas which we have chosen. I'm happy to inform that Dr. Nambi was also part of the project when he was in MS Swaminathan Research Foundation. We all worked together in this particular project. And here we have taken 2 different basins, sub-basins in the Kaveri Basin. The reason is this is a water surplus basin wherein the farmers are entitled to have water for 10.5 months. And this particular area, it's a highly water stressed region. So we have just tried to compare these areas when the water surplus areas and the water constrained area, how the future climate would impact and how we can improve the water use efficiency as well as the productivity. So these are the 2 areas which we have taken, and this is the adaptation technologies, because before going into this project there were 2 feeder projects and which actually have helped us in taking up some of the modeling studies which helped us in formulating this adaptation technology, identifying these adaptation technologies at a location specific level. So we have taken all these adaptation technologies and we have promoted SRI at a large scale because we found that this is one of the most promising adaptation technology. We have actually documented with more than 500-600 farmers. We have documented the yield levels, water use efficiency, and all the biometric observations, everything. Because the SRI, there are many principles. All the farmers are not following all the principles. So we have also segregated that if a particular principle is followed, how much would be the improvement? If they follow everything, how much would be the improvement? So this all we have documented, and these are some of the things. Okay, so these are some of the results. I think because of the paucity of time, I'm just skipping. And we have also done with some of the animal husbandry. So these are the things, and how we can increase the strategies to help in the. So what is the way forward? The way forward is climate smart farming. So one important thing which I would like to stress is the extreme weather events are happening very frequently. So based on our experience, what happened was we are actually closely working with the Kaveri Basin farmers for the past 6 years. The first 3 years, the rainfall was normal, seasonal rainfall was normal, but the distribution was highly abnormal. For example, one particular instant I want to quote is during the southwest monsoon period, they get around 250 millimeters. There was not even a single drop of rainfall during June and July month, but in August month, within 1 week, all the 250 millimeters of rainfall fell, and that year became a normal year, but not for agriculture. So these kind of situations keep coming, so we have to think and work on that line. So the farmer's decision, this has to be something, how much to plant, what to plant based on the expected season. Now we have tools. If the season is going to be like this, we have the tool to integrate this information with the crop model like DSAT or InfoCrop, or with the other one like AppSim. We can find out what would be, if we take this particular option, this would be the impact. So that kind of optional things can be taken up using the crop weather models, and those things can be integrated for farm management decisions to sustain the productivity. So another important thing, like weather-based crop insurance, this will be a kind of a risk transfer solution which we can always think of. So this is some of the gaps which we feel that addressing key gaps in agriculture, especially in the climate service. For example, there are range of climate risk management services for smallholders. Tools and technologies are not available. This has to be built upon. It is available, but the thing is, to their requirement, we have to build it upon. Then access and delivery to carbon markets by smallholders. We identify a lot of carbon credit technologies, but the thing is, it has to be really taken to the farming level, like how to register, what practices, and those kind of things are lacking still, so that has to be taken up. Then integrated water resource management. This is another area which we have to really think about. Integrated network and services. So this is again very important. Early warning and disaster risk management. It is available, but still it has to be improved, because in some 4 or 5 districts, Dr. Naresh Kumar was saying that it's going to the farmers level, so that has to be upscaled. Then climate modeling, weather information, and environmental monitoring. This has to be, these gaps in this has to be filled up. I think I'm done. Thank you very much for your patient hearing.
Thank you, Dr. Geeta Lakshmi, and this is very insightful. Now, Srinivas won't be presenting because of sudden illness, so we have this last presentation by Dr. Ram Kumar. He's a part of the research team, the South Asia Consortium, and he's a lead researcher at the Watershed Organization Trust, and he basically works in watershed management, livestock, and climate change adaptation issues. So I'll request you to finish in like 7 minutes if you can.
I have been chopping out the slides left, right, center since morning. I think I'm left with the minimum. But I'm Ram Kumar, and I'm with Watershed Organization Trust. It's an NGO based in Pune. I come with a different perspective. More from a, as a NGO, we have been in the development sector, and when our initial thought, the topic is from development to adaptation and an approach towards climate resilience. For us, we always used to think, what is it that we are doing different? We are doing development, and it is helping, it is vulnerable. So what is it that we are not doing something that we should be doing? Then, but now it has dawned on us that climate change is here to stay, and we will have to go for some kind of adaptation. And for us also, it is kind of a learning process. So it's like a journey, and it's not cheap in terms of strategizing, going from development to climate, incorporating the climate sensitivity and also the adaptation, getting towards the adaptation strategy. It is very human, both intensive in terms of resources, human and also capital. So that this particular is just a small example how we approach now different development program, and also the kind of vulnerabilities that are not so simple on the ground, and external factor also affect apart from climate change. And this is a general picture. What is clear is that there is going to be, the projections do indicate that there will be temperature changes, temperatures will rise. And for Maharashtra, definitely, since I will be basing myself for Maharashtra state, so there will be definitely 20 to 30% increase in the rainfall in Maharashtra, accompanied by high temperatures of about 2.4 to 3.8 degrees centigrade. If this is the case, then it has implications both for crop and also livestock, water management, and number of concerns. And for us, this was kind of a beginning. And how do we incorporate climate considerations? And what do we mean? So the kind of approach, the continuum approach, it's a development to adaptation continuum approach proposed by actually World Resources Institute, of which Nambi is also here. And this kind of, it provides a very simple way of understanding in a linear manner, but it looks compartmentalized, but then it is quite, the first part, the focus, if you look from the left side, it is addressing drivers of vulnerability, which is what we have been doing. It is irrespective of climate change, what we do to uplift poverty. As we move towards the right, it is building response capacity to, so at awareness levels, and what are the different type of information that we try to build the capacity to build the response to face climate change, and then managing climate risk. That is the part where we now specifically address the what is the climate risk, and for each particular thematic area, even whether it is water, agriculture, livestock, soil, whatever it is, we also now have to plan how do we manage climate risk. That is the additional component that is added up to the addressing the normal way of development. And finally, the confronting impacts of climate change is more like an extreme cases where we have to, either it could be migration or it would be flooding. Because of flooding, we migrate. So it is an extreme. So this gives us a kind of a picture for us. We have used this modified version. How do we operate? Even though conceptually it's nice, but then operationalizing this is again a task. And I give the example of Sangamner as a case. Sangamner again is a taluka in Ahmednagar district of Maharashtra, and it follows in the rain shadow belt. And then the main part where I would like, it is a semi-arid region characterized by frequent droughts, and the drought years between 1970 to 2012. There are about 8 drought years, and the last drought year was in 2012, and then 2003, where this is again the kind of cropping changes. Bajra, pearl millet is the major crop, and it is still a major crop even in 2001 based on in 1991. If you compare 2001, there is a small change. Bajra, pearl millet has come down. Jowar is also coming down. Wheat and vegetables, even though they look very small in our field area, vegetables are now becoming more and more. So it may show as a small change of 3% of the total gross cropped area, but it is one of the major growing area. And from 2003 to 13, this is pearl millet is coming down. Maize and soybean are the ones which are now coming into picture. The reason why I'm showing this is the market factors affect the crops. We may come up with many kind of crop varieties and good strategies we will recommend to the farmers, but ultimately whatever plans we make sometimes go everywhere. The moment the farmer says, okay, the market is pulling the maize or cotton, or here it is also soybean. So our plans have to be changed at the last minute in terms of, and that I will bring into the picture. This is the kind of approach that has been developed. Even though this is now looking as a one slide, to come up to this level, it took us almost, I think, 10 years to come down. We started with securing the income through diversified cropping, integrated farming system, integrated livestock development. But then when we start adding up the climate risk management, we started looking at low external input farming, weather-based agro-advisories, contingent crop planning, water budgeting. So these are the added elements apart from the other normal type of development strategies. And each one, weather-based agro-advisories, it looks very simple to say, but it took 5 years to establish this kind of MET stations, automatic, but then we cannot do it alone. We have to link up with the organizations. For example, in our case, we have linked up with the Indian Meteorological Department. So the data goes to the IMD. They will analyze, give us 3-day forecast, which we will send it to the farmers through SMS. So it's a whole lot, and it is crop specific, location specific, and crop specific advisories. So the moment the cropping pattern changes, we have to change our advisories. We have to start looking at, we map out the growth stages of the crop. We rely on the local agricultural colleges to help us in, and we also actually take the support of CREDA to come up with the contingency plans. So we have a very close link. It cannot be done alone. It has to be in tandem with all the research organizations and whatever resources that are there. That is why I have been saying that climate, the moment you include climate risk, it becomes resource intensive, and the only way you can do is work convergence. That is what we have been trying to do here. And I go to the next one. This gives even another picture. Livestock patterns. The changes between 92 to 97, changes 97 to 2003, changes between 2000. So the red ones are the ones which I would like you to focus, which is 91 to 2003. 2003 is the drought year. And this particular census is very beautiful because it is the livestock census is done in 2003. And what is useful to see is during the drought year, crossbred cattle did increase, whereas indigenous cattle, buffaloes, sheep and goats decreased. That means farmers, either it could be that the big commercial farmers are managing the animals and still retaining and they are increasing, whereas the small and marginal farmers are selling off their indigenous cattle, and the buffaloes are also sold off. Sheep and goats are also decreased, and again afterwards they have again pulled up. But this change is not again so simple. It is very, the person who is selling goats, that's why this is an example of what you call indicating differential vulnerabilities. The person who is selling off sheep and goats is much more vulnerable as compared to a person who is at the level of cattle. The indigenous cattle person probably would be more vulnerable as compared to the person with crossbred cattle. Crossbreds are much more expensive, so the farmers are trying to save them, and while selling off the indigenous and rest of the animals just because of fodder scarcity. So that is one indicator for us that vulnerability you cannot just generalize. It is differential. Each type of you have to categorize, and your plans have to address, your adaptation strategies have to be addressing to each of such kind of target audience. Then, in terms of drought, it is there. I've just mapped out what are the kind of impact and effect on fodder resources. Reduced crop area affects, it reduces the crop residues that are available for fodder purposes. Okay. Similarly, temperature, humidity and rainfall, hot and humid conditions affect the diseases, heat stress and morbidity. The losses due to distress sale, if our strategies have to address such that we minimize the distress sale of animals during that. So we have to come up with such kind of a plan in order to secure the income and also livelihood of that particular category of socially vulnerable category. Then morbidity and mortality. We have been estimating, but there are foot and mouth disease. The reason I am saying is each type of disease has a certain way of becoming an epidemic under certain conditions. If we are clear about which disease, and accordingly we have to organize the strategies. And this is how we map the livestock activities that have to be taken up. For example, if I am again putting in these categories, addressing vulnerability, this is the status as of now, business as usual, where we have veterinary health services, we have health camps, fodder camps in terms of emergencies, and then we come up to but if we want to manage climate risk, then we have to be very clear. Soil and water conservation. Whatever we do as watershed management for soil and water conservation measures under watershed programs will all help in securing this, improving the quality of grazing and pasture lands. Then climate resilient agriculture. So as long as we have assured crop residues, we can still manage something to keep the livestock. Then focus on nutrition. Most often the heat stress and all that, we have to come up with a strategy of balanced nutrition so how do we supply this? It's again very kind of intensive. Training community-based service providers. There is a limit to, again, how much the veterinary resources can be stretched. We need to, again, develop some locally available service resources. So this is how, try to, and then livestock advisory system. This is we planning because we already have a system. All we need to do is link up with the veterinary service department and then try to add additional information into this. This is my last slide. But again, what I would like to emphasize here is inclusion of climate change consideration at planning stage while implementing projects and programs, because it has a lot of implications both in terms of strategizing and also in terms of coming up with realistic way of doing things in terms of budget and also cap. Then to do, it's like a research. You have to do first a little bit of research in terms of what is needed in that particular area, where convergence is necessary. Then a little bit of action, then followed by research. Because again, you are changed. Because otherwise, you cannot really attribute something to climate change or developmental factors, other external factors. So to understand, again, maybe you have to revise your strategy and come back to action again. So this is a kind of an iterative strategy that we will have to, we are struggling to adopt. We are doing it, I think we are doing on those, we are on that path. And then some of the tools that we have used, we have developed as we went through this process is to come up with assess the quick vulnerability, how do we do it, participate in net planning in watershed, community-driven vulnerability assessment. These are the tools through which we see how the farmers are taking decisions. We also try to analyze which is the most vulnerable category. Then accordingly, what are their requirements? Then we prepare some plan and then link up with other institutes. So it is kind of, this is the process. So this is what I would like to convey, that it is not so simple when we start looking at climate, looking at vulnerability. It is not like a broad brush. We have to be very sensitive into that. It is actually differential vulnerability, and our adaptation strategies would have to address these different categories. Thank you.
We don't have much time because the other sessions have sort of ended. So I'll just request Roger if he could come up front and maybe would like to say a few comments, and maybe we can take one or two questions if there are any pressing questions. John, you have some? Or Diane? Murli has. Okay. So we'll take two questions, one from John and one from Murli, and maybe we could address.
Thank you. And across the array of various speakers who spoke primarily in agriculture, I have two questions, which goes to everybody. One is, I always intrigued by, when I spoke to a farmer or a villager, I always got intrigued when I have to convey the message that there is something called as climate change and there is something called as climate variability, or whenever you talk about climate change, because climate change cannot be turned into the local language so easily. So my problem has always been to say what we are thinking as climate change, which has a global connotations as against local issues like annual variation in temperature. So, how have you really addressed this issue? This is my first question to all of these people. And secondly, what I did not realize from across all the people is that because for annual variability, which is akin to climate change, which may ultimately become part of how you make them understand climate change, would be to understand what are their adaptive capacities that it's already existing, and how have you tried to incorporate in your own research, be it organized research such as ICAR and things of that kind, or the less organized or conventional, non-conventional research that you have taken from WOTR. These are two of the major questions, but I have some specific which I'll talk to you in an individual basis.
Yeah.
Collectively.
This is a question for the three speakers on agriculture. pest and disease, agricultural pest and disease burdens are very, very high in South Asia. And some of these, such as plant parasites, actually amplify heat and water stress. And some of the adaptation options we're taking may be making that problem worse, such as switching from paddy rice to permanent bed type of rice production. So how well are you monitoring some of these underlying problems and trying to understand them as you roll out adaptation measures? Yep, pests and diseases, biotic stresses of agricultural crops.
So basically, there are 3 points emerging. One is the local and the global climate change and the pest and disease. Would you like to?
Yeah, probably I would try to respond one after the other, and I expect my other co-speakers also will supplement those. If I leave, I will be leaving many of the issues, obviously. In short, when we go to the farmer, definitely, climate change is not the term to be used. For him, what happened in his forefathers' time and maybe grandfather's time, what were the temperatures? That's how we approach it. That's where he connects immediately. Go to the oldest person in the village. He will tell, our childhood time we used to have this one. Even now we tell, our childhood time our villages used to get more rainfall than now. So they immediately connect to that. That's one thing. And of course, we keep on asking about reasons and try to cross-check with those things. Temperatures, how they were increasing, whether they increased or decreased, what was the rainfall, whether that was similar or decreasing or increasing, whether the intensities, in very, 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 very simple terms. That is one thing. And the second question comes is, in Murali's one more, this one is traditional knowledge. Now you see, Indian farmer particularly is not new to climatic risks. He has been going through these climatic risks day in, day out. He has been facing this challenge. He does have his own, adaptation, whatever we call adaptation. He does it voluntarily, forcibly, or in anticipation. All these things they do. Now, how to really differentiate a good voluntary adaptation or good local technology from the scientifically tested technology? What we try to do is we bring the technology back to the farmers, back to the research field, and try to again refine it and put back to them. Okay, that is one thing, because some of the technologies, if they are really good for that farmer, and there are farmers who really do wonderful. I have several of such examples I can give you later. That take the other farmers to that farm and show that, yes, you see, he is doing, you can also do in a different way. So that is one thing. And test whether that one is really climate friendly. When we talk about climate friendly, when we are talking about adaptation to climate change, probably we need to go for low carbon technology. Otherwise, as rightly said by our chair, that whether today's adaptation is going to be a maladaptation in long run, which we don't want to happen. So this is the second one. The third one related to pest and disease. It's true that in India also we have been finding some of the new pests emerging, some of the pests which were long back there, again coming back into forefront. So institutes are there, they have been working on this, and then forewarning systems, like there is a network of pest monitoring system is there, existent. So that they are trying to, what they are trying to do is, throughout India, they have different places, people, and anything comes, they can click and upload into the website, and that's how it is being monitored now. But of course, it really takes some more time, really, when we come in operational mode in every farm. But otherwise, the efforts are already going on.
As far as the second question is concerned regarding pest and diseases, in fact, around 7 ICR institutes are working entire India and majorly like cotton and some of the pigeon pea, these crops. So they are monitoring, for example, temperature increases, humidity increases, what are the pests are being emerged, and major pests have become minor pests have some and please visit CRIDA website, www.crida. It's a big information, lot of information has been published that how pest and disease dynamics are there in relation to climate change, at least last 5 years experiences. Thank you.
Maybe Geeta will like to.
Yeah, regarding Murli's first question, how do we address climate variability and climate change? No, like the farmers are now very well aware of the climate change, climate variability. The reason is every year is becoming an extreme year. So one year it's drought, the next year it is cyclone and flood, and they lose the crop like that. Now, especially if you just see the last decade, every year is becoming an extreme year. So what we do is we involve the community from the planning of the project level itself. We involve the community, and then we just try to analyze the climatic data. Say, for example, they used to say that, like in the olden days, they get 3 rainfall in a month, like that they used to say, but now it is not happening. That's what is their feeling. So we just, in front of them, we just show the recorded data, we analyze, and we just try to tell them that this is variability and this is the total change. So now we are trying to involve them, like a parascientist, they are coming close with us, and we are trying to tackle that. The second one, traditional knowledge. I was just telling in my talk itself, like there are some traditional varieties the farmers are using. The second thing is, if the rainfall is delayed, automatically they will switch over. Instead of maize, they will switch over to pulse. And then instead of pulse, they will switch over to something very short duration, sunflower. Like that, they have their own system of adaptation. Now, what we are trying to do is, we are trying to validate those technologies. We try to take those technologies, improve them, and give it back to them in the event of extreme weather events. That's what we are trying to do. Coming to the pest and disease question which was asked. In TNAU, we are following one novel method of dealing that. You know, in Tamil Nadu, we've got different agroclimatic zones. In one region, for example, in Coimbatore, in that particular season, the mean temperature is around 28 degrees Celsius means. There'll be another part near to Chennai region, Vellore, the temperature will be 2 to 3 degrees Celsius higher than what is happening in Coimbatore. So what we do is, we just take up the multi-location trials. We introduce the pest artificially. So the pest in Coimbatore and the pest how it is behaving in the region where 2 to 3 degrees Celsius temperature is more. And then, how many generations are taking place? Like that, we do it in a natural way, introducing the pest at different agroclimatic conditions, and we try to study the behavior of the pest. Second thing is, under complete controlled condition, we just try to grow the pest, and from the egg, larvae, and other stages, we try to see how the feeding habit is changing, how the physiology of the pest is changing, like those things. That very advanced level of research is also going on. So this is as far as TNAU research is concerned. I think that answers your question. Thank you.
Thank you. Thank you for the question. Now I'll request Roger to say a few words, concluding remarks, and we'll make it quick. Thank you.
Yeah, it's going to be very few words from me. Just to say thank you very much to all the speakers. I know that you've particularly got to rush off because you have a flight. Thank you very much for the questions as well. I think there are a lot of interesting things in here. Lots of things I could have responded to, and I'm just going to say one, which was it was really interesting, and I'm really pleased to see the recognition of the differentiation on the ground of different people. You know, I think in everybody, recognizing there's not only the different vulnerabilities, but the different capacities, particularly of smaller marginal farmers, the different sort of incentives and help that they may need in order to be able to engage in this adaptation that we are promoting. So I think I'll leave it at that. So thank you very much. It's been a pleasure to be here.
Thank you, Roger, and thank you all presenters and people who chose this session to attend. And we'll have tea outside, and after that we convene for the closing plenary.